Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve the next 10 questions from Descent chapter in Keith Williams' Math book. This is in continuation of a series of lectures in which I have taken up the task of solving all the Descent questions from Keith Williams' Math book. So far I have solved 50 questions. In this video lecture, I am going to solve the next 10, 51 to 60 questions. So let's begin. Question number 51. Simple. At what approximate distance from the threshold of a runway, aircraft will intercept the glide path if aircraft is 2,500 feet above and the glide path angle is 8 degrees. Okay, very steep glide path angle, right? So this is your runway. This is the horizontal distance. This is your glide path angle. This is your aircraft. Okay. Your aircraft is 2,500 feet high. Glide angle is 8 degree. We have to find out this horizontal distance. Okay. So let's use tan theta formula first. Tan theta equals to opposite upon adjacent. So tan of 8 degrees. Opposite side is 2,500 feet. Adjacent side is x. So x equals to 2,500 divided by tan 8. So 2,500 divided by tan 8 is 17788 feet. So divide that by 6080 to convert that into corresponding nautical miles. So that is equal to approximately 3 nautical miles. Okay, 2.9. Next, 1 in 60 rule, angle equals to distance of track, right, divided by distance gone into 60. So here the angle is 8 degree. Distance off track is 2,500 feet. Distance gone is unknown into 60. So distance gone equals to 2,500 into 60 divided by 8. So 2,500 into 60 divided by 8 is 18,750 feet. That is equal to 3.08 nautical miles or approximately 3 nautical. Convert 95 meter per second into knots into feet per minute. We'll do that. So 1 knot equals to 0.515 meter per second. So 95 meter per second will be how many knots? Cross multiply. 95 divided by 0.515. So that is 184 knots. Now 184 knots is equal to how many feet per minute? 184 into 101.3, that is 18686. 18686 feet per minute. If there is a 12 knot increase in headwind, by what amount must the rate of descent be changed to maintain a 3-degree glide slope? So as a rule, whenever there is an increase in headwind, what happens? What is the consequence of that? The rate of descent of your aircraft increases excessively. Your aircraft tends to come down towards the ground surface more vigorously, okay, more quickly, right? So rate of descent increases excessively, more than that is required. Let's say the rate of descent required to maintain the 3-degree glide slope is 500 feet per minute. But upon encountering a headwind or an additional headwind of let's say 12 knots, 10 knots, whatever, the rate of descent will increase automatically from 500 to a new descent rate of 600, 650. Okay, so that means you will be below the glide slope. Instead of maintaining the glide slope, you will come below the glide slope. I will draw that diagram. So this is your runway. This is the glide slope that you are expected to maintain, the 3-degree glide slope. Okay, 3-degree glide slope. What happens when there is at this point of at this place you are getting just this much headwind. A few minutes later, the headwind component increases. So what will happen to your aircraft position? It will end up being somewhere below the glide slope, somewhere here. The rate of descent of your aircraft will increase. The rate of descent of your aircraft will increase. So what is the solution to stop this excessive rate of descent, to come back to your glide slope or to catch your glide slope and then maintain a steady rate of descent required to maintain that 3-degree glide slope, correct? So the solution is pilot must add power. This addition of power will increase your speed, increase your lift, and slow down your rate of descent. Okay, pilot must add power and increase, decrease and decrease this excessive rate of descent and maintain normal, steady rate of descent. Okay, next. So the change in rate of descent required is equal to 5 into is equal to 5 into change in speed, 5 multiplied by what happens when there is an increase in headwind. The ground speed of your aircraft will decrease. So 12 knot increase in headwind means 12 knot decrease in ground speed, so minus 12. So 5 into minus 12 is 60, minus 60 feet per minute. So the change in rate of descent required is minus 60 feet per minute, meaning you will have to decrease, the pilot will have to decrease his rate of descent by 60 feet per minute. What will be the rate of descent when flying 7% slope at a speed of 540 knots? So formula is slope equals to tan theta into 100. So 7% equals to tan theta into 100. So tan theta equals to 7 by 100 is equal to 0.07, right? So theta will be tan inverse 0.07, which is equal to 4 degrees. Now use the direct formula. Rate of descent equals to glide angle into speed in feet per minute, so 101.3 by 60. So 4 into ground speed 540 to 101.3 divided by 60. So 4 into 540 into 101.3 divided by 60 is 3646.8, or approximately 3650 feet per minute. That is your rate of descent. Okay. So next. Aircraft is flying on a 3-degree glide slope 35 miles away from a DME station. Use 1 in 60 rule. Okay, 1 nautical mile equals to 6,000 feet. Calculate aircraft height above the runway threshold if ILS glide slope crosses the threshold or crosses over the threshold at 50 feet. Okay, so this is your runway, this is your glide slope, this is the horizontal distance, right? Now this glide slope passes at a height of 50 feet above the threshold of the runway. Now make this triangle complete one. So if this is 50, this will also be equal to 50. This will be x. This will be your aircraft here. Okay. 35 miles away, and the glide slope is 3 degrees, standard glide slope. So let's use 1 in 60 rule formula in this triangle. So angle which is 3 degree equals to distance off track divided by distance gone into 60. So 3 into 35 by 60 is 1.75 nautical miles, which is equal to 10,500 feet. Okay. So this x is 10,500 feet. That means this aircraft is 10,500 feet above the threshold at a height of 50 feet. Above 50 feet threshold elevation. Okay. So aircraft is 10,500 feet above the threshold, above the glide slope, which is at 50 feet above the threshold elevation, basically. So the total height will be total height of aircraft with respect to the threshold ground surface is 10,500 plus 50, which is equal to 10,550 feet. So this will be your final answer. Okay. Next, 850 feet per minute equals to how many knots? Where 1 knot equals to 101.3 feet per minute. So 850 feet per minute divided by 101.3 equals to 8.3 knots. 8.3 knots. If there is a 35 knot increase in headwind, again, increase in headwind means excessive rate of descent as a consequence. Solution is decrease your rate of descent, right? So the decrease in rate of descent will be equal to 5 multiplied by change or decrease in your ground speed. So 5 multiplied by minus 35. Why minus 35? Headwind increases, ground speed decreases. So 5 into 35 is minus 175. Okay, so you will have to decrease your rate of descent by minus 175 feet per minute. Next, what will be the rate of descent when flying down a 10-degree glide slope at a speed of 400 knots? So rate of descent is slope into speed into 101.3 feet per minute is equal to divided by 60, which is equal to 6753 feet per minute. Okay, rate of descent equals to 6753 feet per minute. Aircraft is at flight level 370. It commences descent 120 miles away from a facility and crosses the DME at flight level 100. Ground speed is 390. What is the rate of descent? Again, rate of descent is change in height divided by the time taken. So you're descending from 37,000 to 10,000, so a height of 27,000 feet. Now the time taken to effect that change. Time can be, it can be calculated using speed distance time formula. So time equals to distance divided by speed. So what is the distance? You are 120 miles away. The speed, your descent, the cruise speed, ground speed is 390 knots. 120 by 390 is 18 minutes. Okay, so 18. 27,000 divided by 18 is 1,500 feet per minute. Simple. Last but not the least, aircraft is descending down a 10% glide slope. So the usual formula, slope equals to tan theta into 100. So 10% equals to tan theta into 100. So tan theta will be equal to cross multiply 0.1. So theta will be equal to tan inverse 0.1, which is 5.7 degrees. So theta will be 5.7 degrees. Rate of descent is slope angle multiplied by ground speed in terms of feet per minute. So 101.3 divided by 60. So 5.7 degrees into ground speed of 540 into 101.3 divided by 60. So 5.7 into 101.3 into 540 divided by 60, 5196. 5196 feet per minute or 5200 feet per minute. Easy. So this brings us to the end of this productive lecture. I hope you have understood all the questions that I have solved in this video lecture. You have learned something new today. Practice is the key. The more questions you practice, the more confident you become, the more familiar you become with the exam questions, and the fear of exam goes away. All the best of luck. Take care. In my next video lecture, I will solve the next 10 questions, so don't miss that.